Hi guys, today I'm going to show you my 3D printer. It's the Renkforce RF1000. It's made by Conrad, a German manufacturer. Yeah, as you can see, there are some pretty nice LEDs in it, so it doesn't add any function, but it gives a nice look to it. So the build volume is 25 by 24 centimeters and about 18 centimeters high, so roughly 10 cubic decimeters. The frame is made out of aluminium. It's a pretty robust frame, and it gives the possibility to add a second rail on it to add a mill on it, so you can mill parts. And later in the year there will also be an upgrade to upgrade it with a laser cutter, so that would be pretty unique for a standard home printer. So yeah, looking forward to it. The print table is made out of ceramic, so pretty hard, scratch resistant, good material. It's heatable, so very useful for printing ABS parts to prevent it from warping. So yeah, it sticks better to the surface. The built-in display, I'm not sure if you can see it on the camera, allows you to automatically calibrate the Z-axis. So you take a virtual scan to measure the heights and depths of the table actually, and it does that by using a pressure cell. So this is the pressure cell, and it allows you to, when the extruder measures the table, it will reach a specific force, and when it reaches the force it will stores up the coordinates in the Z. So, and it does that for many different points on the table, and on software you get a virtual image of the how even the table is. Also, you can, of course, with the buttons manually control the Z axis, but you can't control the X and Y. You can only do that by using your computer, by plugging it in with a USB cable. Of course, you can also use a SD card slot, and from there you can, via the interface, you can choose which G-code file you want to print. Also, a big advantage of this printer is that it's capable of printing almost any material that is out there for a 3D printer. So it's capable of printing laywood, ABS, PLA, HIPs, also metals, so it combines metal powder with a binder, and that makes it possible to print metals with it. So yeah, let's do a little demonstration on the Z calibration, so the heat bed scan. It's pretty unique for a printer. Most printers don't have this feature. So first of all, we have to heat up the bed temperature to about 100 degrees Celsius. And when we go back to the main menu, we see that the target temperature is 100 degrees for the table, this is the temperature for the extruder, which is currently 19 degrees room temperature. And yeah, as we can see, it's rising to 100 degrees, and when it reaches the temperature, we can start our heat bed scan. Okay, so as we can see, it has reached the target temperature of 100 degrees. So now it's time to heat bed scan. So we go to configuration and heat bed scan. Now my cat is behind the printer, so I have to be careful. So right, let's try it. Heat bed scan, and I'm starting, and there it goes. So what it does is it moves the extruder down towards the table, and when it reaches a specific force, it will store the coordinate in the z-axis, and then it goes to the next point and the next, and until you have about all the surface area of the print bed. So most printers you have to do this by hand, so it takes some time, and yeah, maybe more chances on getting fault or yeah, errors during the calibration. So it's very useful. Also, yeah, I've got some materials down here. These are pretty standard materials. We've got PLA, 3 millimeters in diameter. That's HIPS, also 3 millimeters, and then we got ABS with 1.75 millimeters. So I've got a standard storage of materials, different colors. So alright guys, that's my time. See you in the next video.